Welcome to the Broadtek and Promwad podcast, where we unpack the trends and tech transforming the AV and broadcast world. Today's focus, software-defined solutions and synchronization. Find out how flexible software architectures and precise timing are powering the next wave of scalable, interoperable AV systems.
There's a push towards more software-defined solutions, things like virtual audio mixers and things like that. So, from your side, what do you see is the difference between that FPGA way of developing to a more software-defined?
My basic commercial logics is that, difference between hardware and software-defined devices or things is your hardware has a specific life cycle, right? And you depend on the components. So in case you want to produce another batch of the devices and the components are not available, you have to update the hardware and manufacture a different set of devices with different set of hardware, and that could be a problem for the legacy software. You have to update the software, etc. So that makes you updating the device constantly in terms of hardware and software according to its life cycle. However, if you have the software-defined equipment, it means that you have to enrich only the software with the features. You are hardware agnostic. Yeah. You can just store it in the cloud and update it constantly.
Exactly.
And hardware is not your problem.
And from that perspective, what I want to really touch on there is that hardware's got a life cycle, right? And when you're, from a manufacturer's point of view, if you're investing lots and lots in hardware, you've got, capital invested in there, warehousing and everything else. With a firmware update, you can update those things. And I'm seeing a trend, and I'm seeing one of the things, I'm actually working with a client at the moment, and I'm advising them on a roadmap that is going software first, hardware complemented. What I mean by that is that the hardware really acts as a control element, and the software is what is the driver. Yeah. And in that way, you're extending the life cycle of your products because you're not there going, I'm still using, I don't know, VGA or processing or anything else that in 5 years' time might be obsolete. Yeah. You are essentially only using the hardware as a tactile surface to be able to control the software elements. And that seems to me, and then, in conjunction with the cloud, remote diagnostics and everything else that, around that, and how system integrators are going to change in the future. Today, they need to go out in the field. Tomorrow, they really need to be IT engineers. They really need to be, focused around working around custom solutions so that they can make a bespoke solution for whether it's a funeral home, whether it's a sports bar, or a lecture theatre. It doesn't matter what it is, they create that custom solution for them, and the software is the driver, and the hardware is only the interface as such.
Absolutely. Yeah, we also see this tendency that customers, they want to be more hardware agnostic to deliver more value in software to their customers, which is a trend I completely agree with.
Yeah. And going towards that future, I think the other side of it is also the benefits of the chip manufacturers, because I think a lot of the chip manufacturers are now trying to incorporate within their chipsets a lot of the functionality that you might be looking for in an FPGA, but you want a low-cost chip that also does video rendering or does all of that, and they're incorporating that in there. So I think the future is bright in terms of bringing down the overall cost, and also giving a lot more versatility to their to the customers. Age-old problem: synchronization of audio and video. Talk me through that.
Yeah, it's very interesting. So if you need to get just audio, it's not let's say very easy. But when you work just with audio or just with video, and you need to decode it and to show on the screen, it's really not complicated. But when you get everything, you need to synchronize it, and especially if you need to meet the latency. For IP-based, you can use buffering on the device, and you can put second, 2, 3, and it would work, everything would be fine. but the latency would be awful. So, for example, if we're talking about the VIP rooms, where the stream should be delivered with the lowest latency, because some kind of monarchs, they do want to see everything like they are behind the field. So the latency should be around 100 or even not more than 250 milliseconds. In this case, you can't just buffer in video, or how to say, you can't just play with buffer. You need to implement carefully the decoding part of the streams. So only in this case, the latency would be really low. And it's quite doable for different kind of projects. For the legacy device, we achieved the latency of around 300 and maybe 60 milliseconds. And for the latest, if I'm not mistaken, it was between 100 till 150 milliseconds, if we're talking from glass to glass.